Assalamualaikum and a very good morning to all panels. My name is Roida Shamsuddinaidi and today will be presenting on my research study on synthesizing the N-substituted Pyrrolidine-2 3-dione from ethyl acrylate. This whole study has been supervised by Professor Dr. Zurina Shamari and was co-supervised by Dr. Nur Hidayah Pumut. A bit introduction about pyrrolidine and pyrrolidine-dione ring. Both of these compounds are a saturated 5-membered ring with the attachment of nitrogen atom in the ring. The only difference with the pyrrolidine-dione, it has 2 sets of carbonyl group attached in the ring. Both of these compounds can be found naturally and also can be produced synthetically since it has multiple benefits upon its biological and physiological properties. Based on several research papers and journals, there are 3 synthesis methods that were commonly used to synthesize this compound, which is one-pot reactions, which is also known as multi-component reaction, MCR, and then we have dominance reactions, and also the multi-step organic synthesis reaction. For this experiment, I have chosen to use the multi-step organic synthesis reaction since it offers many advantages than the others too. For example, this kind of method has provided me a high yield product compared than one-pot reaction and also dominance reaction. The reason why I conduct this kind of experiment because of the problem of the numerous steps and processes involved to synthesize the N-substituted pyrrolidine-2 3-dione. The more steps performed, the more chemicals and reagent will be used, and of course, it will consume more money and time. So in this work, I had proposed an efficient and shorter synthetic route which can produce high yield of targeted compound. From this research, I believe that our science communities can get a handful benefits, especially for our researcher teams, chemistry students, and also educators. This research can provide alternative ways to solve scientific problems, and the result also can obtain to be used as a reference data or also as the starting tools in conducting new research. Well, the main objective of this studies is that I want to synthesize a series of N-substituted pyrrolidine-2 3-dione using different alkyl or arylamine as the starting material via Micheal addition reactions, cyclizations with oxalates, and also decarboxylation reaction. Next, I want to apply the spectroscopic techniques such as NMR spectroscopy and also FTIR spectroscopy to characterize each of the compounds. Back in the days, there are few numbers of reported papers on this 2-3 system of pyrrolidine-dione. So, due to its outstanding biological and medical properties, it started to gain the popularities among the researchers. Several authors also have agreed on using the same method to produce this scaffold where the moiety of this 2-3 system of pyrrolidine-dione ring involve several reactions such as Micheal addition reactions, cyclizations, and also decarboxylations process. So it also mentioned that the product of the cyclizations and decarboxylation reactions tend to be analyzed and existed as an enol tautomers. So tautomerism occurs when there is a migration of a proton and causing continuous switching of the single bond and its neighboring double bond. So ketol enol is one of the famous tautomerism process other than amine-imines and also thiol-thiol. Addition of either acid catalyst or basic catalyst also can induce the tautomerism effects as well as self-promoted involving direct intermolecular proton transferred by any 4-membered transition state. So over here we can see the overall outline of the N-pyrrolidine-2 3-dione synthesis, where over here is the first step reaction involving the Micheal addition reactions, and the starting material that I used were methylamine, benzylamine, and also propylamine. And then over here is the second step reaction, which is the cyclizations with oxalate. And then over here is the last step reaction, which is the decarboxylation reactions. So for result and discussion part, I will explain it one by one, part by part, starting from the first step reaction until the last step reaction of decarboxylation reaction. Okay, so over here, we can see the first reaction step with its mechanism. So my intention was to condense the primary amine. Okay, so over here we have benzylamine with ethyl acrylates to form the beta aminopropionates. In order to fuse the amine functional group to the beta carbon of the ethyl acrylates, Micheal addition reaction will be applied. Since ethylamine is an alpha beta saturated unsaturated carbonyl compound, amine will uh, amine will act as the donor, and it will attack the electrophilic beta carbon of the ethyl acrylates. Okay, and then this solvent ethanol will aid the nucleophilic addition reactions. Okay, after the reaction take place, okay, we will check the product with the with aids of TLC plates, and then we will characterize it using NMR spectroscopy and also ATR FTIR spectroscopy. For the first step reaction, I have used 3 different kinds of starting material, which is the methylamine, benzylamine, and also propylamine. Okay, after the reaction have took place, I've checked the spots for the new product using the TLC plates, and then I count for the percent yield. So over here we can see that benzylamine has the highest percent yield compared to methylamine and propylamine. Okay, the reason why propylamine has the lowest percent yield at 25.3% is because it has to undergo purification technique using the column chromatography. Okay, after that, I'll proceed with the characterizations process using the spectroscopic technique. Since benzylamine has the highest percent yield, I have choose the ethyl 3-benzyl aminopropionates to be proceeds for the second step reactions. Okay, on to the second step reaction. The earlier product of beta aminopropionate, which is ethyl 3-benzyl aminopropionates, underwent the condensations, and cyclization reactions under dry conditions to form 2,3-dioxypyrrolidine 3-carboxylates. So first, beta aminopropionate will act as the starting material, and it will condense together with the diethyl oxalates. And then once the beta aminopropionate coupled together with diethyl oxalate, okay, cyclization reaction will occur with the aids of sodium methoxide to form the 2,3-pyrrolidine-dione ring system. Okay, sodium methoxide is actually a base, and it will deprotonate the alpha hydrogen over here, and it will form enolates and ion. Okay, then the enolates and ion will attack the carbonyl carbon of the diethyl oxalate, and it will form a ring. Okay, for the last step of decarboxylation reaction, I was not be able to perform it due to the lack of time of laboratory work. Thus, this part of decarboxylation reaction was done using research papers, some articles and journals that have been published on several online platforms such as Google Scholars and also Science Direct as references. Okay, so what I did was that the end product of an alkyl or aripyrrolidine 2,3-dione was proposed and predicted based on the reports of previous authors that have been sharing the same techniques and procedures during decarboxylation reaction steps. So over here we can see that this is the beta keto ester that will undergo decarboxylation reactions with the aids of hydrochloric acid and form N-benzylpyridine 2 3-dione. Okay, the rule is for a beta keto ester to undergo decarboxylation reaction, it has to undergo hydrolysis process first to form into beta keto acids. Okay, then over here we can see that there are intramolecular hydrogen bond that form between the carbonyl oxygen, okay, which is over here, and then the OH of the carboxyl group. Okay, then what will happen is the rearrangement will occur that will eliminate the carbon dioxide gas. Okay, to conclude everything, I must say that the entire objectives were not entirely fulfilled due to the incomplete work of decarboxylation reaction due to the lack of time for laboratory activities. However, the first and second reactions were managed to be done with excellent yields, especially for product with starting material of benzylamine. The unfinished part of decarboxylation reaction were done based on the reported papers and journals. Thus, I've come to a decisions to propose the mechanism and predicted the structure of end product of N-substituted to pyrrolidine-2 3-dione, which is the 1-benzyl pyrrolidine-2 3-dione. Okay, as for the recommendation part, maybe I can suggest that other researchers to try other kinds of starting materials, and then they need to ensure that the starting material is fully reacted with the solvent or the reagents, and then it is better to use a freshly prepared sodium hydroxide during the cyclization process. And that brings us to the end. I would like to thank you for your time and attention today. And also a big shout out for Professor Dr. Zurina Shamari and also Dr. Nohidayah Pungut for helping me to finish this entire research project. I sincerely appreciate that I have this opportunity to present to all of you. Thank you. Assalamualaikum warahmatullahi wabarakatuh.